They walk past them every day and never noticed. To most people, a shipping container is nothing more than a dull, rust-streaked steel box, a temporary storage unit on a dock, a stack of rectangles on a freighter, a rectangle behind a warehouse. But under the surface of routine commerce, something far darker and far more consequential has been quietly taking shape. In the shadow of global trade, entire arsenals have learned to hide in plain sight. This is not a story about secret bunkers or underground layers. It is about ordinary steel boxes. Boxes that move, unnoticed, across oceans, rails, and highways, suddenly becoming instruments of war. The concept is so simple that it feels impossible. Cruise missiles, drone swarms, anti-air systems, even colossal, kilometer-long defensive barriers, all folded, fitted, and concealed inside containers that blend into the world's supply chains. The smallness of the idea is precisely what makes it terrifying. Imagine a single shipping container, locked, sealed, and unremarkable. Now imagine that inside that box is a vertical launcher, or a pallet of loitering munitions, or an array of electronic warfare gear that jams radars and sends networks into silence. Imagine a dozen such containers spaced across the decks of a commercial cargo ship, or loaded on trains and trucks, or parked at a terminal near a naval base. From site to launch, the distance between invisibility and devastation is suddenly very short. It wasn't born yesterday. The idea of masking weapons in civilian-looking vehicles has been around for generations. In World War II, Q ships masqueraded as merchant vessels while hiding heavy armament to ambush submarines. Fast forward to the Cold War and beyond, and militaries were already experimenting with containerized launchers and concealed armaments. Programs from the 1980s and early 2000s proved that cruise missiles and other potent systems could in fact be adapted to fit inside standard shipping boxes. Once the engineering hurdle fell, the strategy shifted from theoretical to practical, and the world changed. What makes containerized weapon systems so lethal is their several-fold advantage: stealth, mobility, and modularity. A shipping container uses the world's civilian infrastructure as camouflage. It rides on the same ships, trucks, and trains that carry consumer goods, grain, electronics, and cars. No special facilities are needed. A containerized system can be transported nearly anywhere a box can go, and it can be placed close to a target without raising immediate suspicion. This mobility multiplies the strategic problem. A single container on a freighter at sea is difficult to track. Hundreds of containers on a commercial vessel create the potential for an entire floating arsenal, distributed like chess pieces across the global maritime board. The element of surprise is not theoretical, it becomes operational. Multiply that element by hundreds on a single vessel, and the simple act of shipping becomes a weaponized strategy. The diversity of systems that fit into containers is sobering. It's not just cruise missiles. Drone swarms, dozens or hundreds of small unmanned systems can be launched from containers. Electronic warfare suites, designed to blind or confuse radar and communication networks, can be packed into a single unit. Loitering munitions designed to strike hardened targets can be housed and launched through relatively compact mechanisms. Even conventional heavy weapons, like miniguns or automatic grenade launchers, can be adapted into modular containerized packages when combined with modern remote control systems. The box becomes an assembly of lethality. History shows the concept's viability. Military experiments and programs over decades proved what engineers suspected: containerized systems work. More recent demonstrations and systems around the world revealed the breadth of the idea, from 4-cell launchers that can hold cruise or anti-air missiles in a 40-foot container, to systems that can be truck transported and set up on the fly. Nations with maritime ambitions or sizable industrial logistics networks quickly recognized the strategic elegance of weaponizing containers. For some states, integrating military capability into commercial shipping becomes not just a possibility, but a deliberate doctrine, a way to multiply force projection without the obvious signs of a traditional navy or army. And then there are the real-world operations that blur fiction and fact. Smuggling drones inside seemingly innocuous cargo, hiding launch mechanisms behind false walls, or using modular homes and trucks to conceal cache and launch sites. These are not hypothetical anymore. One operation demonstrated how hundreds of small unmanned aircraft could be smuggled into contested territory, hidden under the everyday trappings of civilian cargo, then released to devastating effect. For defenders, the nightmare is not just one attack, it is simultaneous or near-simultaneous strikes on multiple fixed points. That kind of coordination turns isolated tactical successes into a strategic shock. If this sounds like a scenario for state actors, there's a good reason. Mounting a complex containerized missile attack usually requires logistics beyond the reach of lone actors. Missiles are heavy, sensitive, and demanding of specialized handling. To be effective, many such systems have to be top-stacked on a vessel, exposed enough to launch, a detail that requires planning, cooperation, and facilities. Those are not trivial constraints. They make large-scale missile launches from commercial ships most likely to be the work of a well-resourced state, not a handful of conspirators. Drones, by contrast, are the great equalizer. Smaller, cheaper, easier to conceal, and harder to interdict at scale. Unmanned systems can be launched from side panels or from within a deck-mounted box. A swarm deployed from containers can overwhelm sensors, saturate defenses, and crucially, strike specific weak points while a fleet is docked and vulnerable. The most dangerous moment for a warship is not on the open sea, where defenses are active, but when it sits in port. Systems are often in standby, maintenance is underway, and critical sensors are less responsive. Embedded drone attacks need not sink a ship to win. Disabling sensors, knocking out radar arrays, or destroying a handful of aircraft on a carrier's deck can be strategically crippling. For a military that relies on integrated air and missile defense nets, the consequence is stark. A focused operation that hits a ship's primary radar arrays can blind the vessel's ability to detect and engage incoming threats. Replace one ship with several, and coordinate attacks across multiple bases, and the damage compounds. Replacing complex radar systems is time-consuming. Production bottlenecks make the recovery slow. The strategic defeat then extends beyond momentary loss. It becomes a window during which an entire theater's operational posture is compromised. Defenders have responded with a variety of measures, but the calculus is complicated. Scanning every container, the instinctive answer, is logistically impossible without strangling global trade. Millions upon millions of containers cross borders each year. Even a modest inspection regime would create supply chain gridlock, raising costs and sparking diplomatic crises. The economic baseline of modern civilization depends on the flow of goods. Choking that flow to inspect every steel box would be an attack on commerce itself. So if universal inspection is infeasible, what else remains? The emerging answer lies in layered adaptive defenses that focus on detection, rapid response, and distributed resilience. That means investing in technologies and tactics that can spot anomalous behavior, detect unusual signatures on vessels and terminals, and deploy mobile countermeasures capable of neutralizing threats before they escalate. One promising approach is mobile, integrated air defense deployed at scale across vulnerable installations. Systems that combine radar and command vehicles with mounted firepower, rapid response units that can relocate, detect, and engage small, fast targets, are becoming the backbone of base defense. Imagine a pair of light-armored vehicles. One operates as a radar and command node, scanning for aerial anomalies and coordinating the network. The other is armed with short-range interceptors, a rapid-fire cannon, and electronic measures. When spread across a base in sufficient numbers, these mobile units can create a flexible, layered shield designed to stop drone swarms before they reach critical assets. Electronic warfare also plays a leading role. Modern drones often rely on GPS and networked control. Spoiling those channels can turn an attack into a scramble. Yet with the rise of onboard autonomy and AI navigation, the classic approach of jamming signals may no longer be enough. Autonomous swarms can adapt, reroute, and complete missions even under degraded communications. This raises a much deeper problem. Defenders must deny not only the link, but the effectiveness of the autonomous algorithms themselves, whether through deception, cyber interference, or by eliminating the swarm's sensory inputs. That is why the future of defense looks less like static walls and more like active